Hi and welcome to another 5-minute session, and today it will be about texture, and the texture will be gradient. So I press Shift A, go to texture, and I select the gradient texture. And gradient texture is like a lazy way to do stuff because it's one node that creates stuff that you can do in other ways but then needs a little more nodes, and I will go through everything. But we can start from the beginning, taking the UV to the vector of the linear and take the factor here or the color, it doesn't matter in this case, you can see it exactly the same thing. And you can see we get from black to white here. And if you have seen my other 5-minute courses, you know that we can get this in another way rather easily by just taking the UV and then separate X, Y, Z. And take the X here, and you can see there is no difference at all. They are exactly the same. So that is the linear. The next one is quadratic. You can see it gets a bit smoother here. So when you're using quadratic here or quadratic sphere, they get smoother. How to get them smoother is often just by adding a power of 2 after the value. So in this case, if I add power of 2 here, so power and 2, and I exchange those two, you can't see any difference at all. It's the same thing. So these two we could do rather easily. The next one is easing. I'm not really sure how the math is for easing, but that doesn't mean that I can't recreate this pattern, because what I can do is take the separate X, Y, Z. I don't know why I destroyed it. It's like the default cube. You have to destroy to get it back. But what we can do here is that we can use the color ramp. We have not gone through that yet, but we can do that later on. So I go to converter and I have a color ramp. And if I take the X here and I just change this linear to ease, then I get exactly the same result. If I use the linear or cardinal or something else up here, I get another result. But with easing is exactly the same thing. So we don't need a gradient texture for that. We can use this as well. And the next one is the diagonal. And now you can see it's down here, because the gradient texture works exactly as the UV says it should do. So even for the gradient, the origin or the center point is down here. So if it's something that is like a circle or it's diagonal, then we need to move that to the center. So we can do that. Shift A, and then I go to converter and vector math, put in a subtract, and change the top 2 to 0.5. And I also add a multiply to get it to 1. So Shift D, multiply, and 2 here. So now we have the diagonal, and to get that here we can use this subtract, put it here, but we change it to multiply, and then we take X and we add that with the Y, and of course we also need to have that from this one. So now you can see no difference at all. The same thing. So that is how diagonal works. The spherical, we have done that already. You know, it's just the length. So if you use the length and then subtract with 1, you will get the spherical here. And the quadratic spherical, well, I can show you. So it's the length, as I said. We subtract with 1. Or we use 1 subtracted with the length, so we have this in the bottom. And since it's a quadratic, you add a power of 2. So power of 2, and we have the same. But now you can see there's a ring here. To get away with that is just to set it to clamp here, and then we get exactly the same thing, as you can see. So we can do the quadratic sphere as well, but it's good to know that it's in the gradient. And the last one is radial. I will take that later on because it's a chapter of its own. It's called polar coordinates, and normally we use Cartesian coordinates, but how we do the conversion I will take in the next chapter. So that was the gradient texture. So I just say bye for now and see you in the next chapter.